So those of you who don't have a protractor at home or who want to have a little bit of practice without having to get straight down to doing your work, I'm going to show you a really easy way to have a go at playing around with different angles at home. So type in to Google maths frame measuring angles, and it is your first result on Google that you want to click on. Scroll down, all the way down to this one here. It's called ITP Fixed Points, and that would just open Play Game, and it should open on your screen. So I'm going to make my grid a little bit more complicated, and I'm going to use this icon here to create an angle. So I'm just going to be a bit generous with my angle. There's part A, part B, and part C. So you can see that B is where the angle has been created. This is our vertex. It's like a corner or a point. And what I'm going to do is I'm going to click on this button here, and it will bring me up a nice protractor. So as I was saying in my previous instruction video, you need to line up this point here, this cross, or the little circle that you might have on your protractor. In this case, the 0 line is right on the edge here at the bottom. You can see that because this must be 0 if this is 10. This is 5, this must be 0. On your plastic protractor there'll be a black line and there'll be a bit more clear plastic here. So just bear that in mind if you're doing this by hand at home. So you need to line up this central point on your vertex. So I'm going to move this all the way up to approximately the middle of where B is, where I think that point would be in relation to the others. So right in the middle of that vertex. And I'm going to use this blue button to straighten up my protractor here, so that I've got the line from C to B beautifully, carefully and accurately along this 0 line here, all the way up to that vertex there, where the central line of my protractor is sitting. So then I'm going to have a look at the 0 point, always starting from 0. So I've got 0 degrees here, 10, 20, 30, 40, well, I've got 50 degrees, but I can see that there's a few more here, so 51, 52, I'd say that's 53 degrees as an angle. So angle B here is 53 degrees. So we're thinking about different angles. We need to remind ourselves of the different kinds of angles that we can have. I can tell you that this particular angle is an acute angle because it is less than 90 degrees. Here's our 90 degree line, and this angle is less than that. It's 53 degrees. So let's try a different kind of angle. So if I reset this, I'll move my protractor out of the way. I'm going to try a different kind of angle. I'm going to try an angle that looks a bit like this. So here we've got another kind of angle, and I want to measure this measurement here. So once again, I'm going to bring my protractor across. I'm going to sort of straighten it up a little bit. I'm going to line up the central point on the vertex, on the corner where B is, and I'm going to bring this 0 line up. So lining up, I can see actually this isn't quite as accurate. I'm going to bring this down a tiny bit, and then I'm going to, it's very, very accurate, you have to be very careful. It looks like I've got this line here between B and C, all along this 0 line here. So I'm now going to count from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It looks like A is right on 110. It might just be 109.5 or something, but I'm going to go with 110. So this angle here is what is 110 degrees. Now this kind of angle is greater than 90 degrees, so we call it a obtuse angle. It is greater than 90 degrees, but it is less than 180, so we call it an obtuse angle. Sorry, an, not a. It's an because obtuse begins with a vowel. If we just have a quick look here, we've just had a look at an acute angle, an angle that's less than 90 degrees. We can see that it's a smaller angle than 90. It's acute, it's small r, isn't it cute? That's how I remember it. An obtuse angle, which is we've just looked at, is greater than 90 degrees, but it's not as big as 180, so it goes up to 179 degrees. So it doesn't go, an obtuse angle isn't a straight line, it's just smaller than a straight line. So let's have a little look at a right angle on our maths game. So we're going to reset this, going to move this here. Now a right angle, I know that a square has a right angle, so I'm actually just going to draw. Here we go, here's a, is that a square? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. If I give this shape equal sides, 4 equal sides, I know that each of these angles will be a right angle, because that is the amazing property of a square. So I'm just gonna look at B again. I could look at D or A, and I'll show you how we could measure those in a second. So we're just going to check that this is a 90-degree angle. Oh, that's not quite on the line. Yep, so here we go. This is a right angle. So you usually see a right angle drawn with a square in the corner to show that it's a right angle. And if this is a right angle, the opposite must be the same. And we'll talk a little bit more about that in the other video that you may want to go and have a look over again. Now imagine I ask you to measure angle D. What I would say to you in a lesson is I'd say to you, move your paper around so that it gets D angle is where B is, but you can move your protractor as well, so we can just sort of turn it upside down like this, put that right in the middle there, move the 0 line. I can see that's not quite in the right place. I'm going to try that again, and I can see that this angle, when we measure it from the 0 line, is also 90 degrees, so I have indeed made a beautiful square. So that's our right angle triangle. Let's have a look at another kind of angle. So we've done right angle. Right angle is always 90 degrees. Acute angle is always less than 90. And obtuse is always between 90 degrees and 180. On here it talks about a straight angle. That just means a straight line, and that is 180 degrees. So the last one I want to show you is a little bit more tricky on this program. It's called a reflex angle. And this is any angle that is greater than a straight line, greater than 180 degrees, but is less than 360. If we think of this circle being 360 degrees, we are usually only given an 180 degree protractor. So how on earth can we measure this? Let's have a look on our computer program. So let's move this out of the way. So I'm going to draw this angle here. Now, we have been measuring this inside angle here, but if we were to be looking at a reflex angle, we're going to be looking at the angle around the outside. So for example, if I just draw it on here, this is A, it's a very terrible drawing on this paint pad, B, remember I've used a lovely ruler, of course, and then we've got C here. So a real massive apologies about the terrible drawing. Now we've been measuring this inside angle here. The reflex angle is actually this angle on the outside. So we're actually measuring the distance between this point here all the way around to this point here. Now I can't do that on my protractor. It's not possible really on here. So what I am going to do is I am going to measure that inside angle, and then I'm going to do a calculation. So let's have a quick measure of that inside angle. I think I need to get my protractor. This is quite a clever protractor because I can switch the way that the numbers go, which is I'm actually going to use that feature right now. So I'm going to line up my protractor where B is right on that vertex there, right in the middle. I'm going to bring this in line on the 0. Still looks a bit wonky. There we go. And I'm going to use this clever button here, which is going to switch my numbers. So I'm going from 10, and the measurement is about 45, 46, 47. It's about 48 degrees. Now if I couldn't do that, if I didn't cheat then, I could measure where the line is here. It looks like it's about, this is about 132. So basically I'd do 180, take away 132. But it's up to you how you work that out. Anyway, what we've said is that this angle measured here is about 48 degrees. So if I take this away, I know this angle here is 48 degrees, but I know that a whole circle is 360. So if I do 360 take away 48 degrees, I will know what the remaining angle, reflex angle, is around the outside. So I'll do another little video to show you how we can do the first task that we're setting you for working out angles and problem solving with those, so that you can get started with your task. Obviously, if you don't have a protractor at home, you can use this program to help you, and there are online protractors that you can use as well. So we'll set you some work and I will talk you through the first task using the same approach.